Just today I was approached by a very real and existing person who came up and asked, Maxwell, what is a camera? And I said, well, completely non-fictional person, I'm glad that you asked, because I was just thinking about how a camera is a system. And I told them all this stuff that I'm about to tell you, and they walked away and said, oh, thank you so much. I feel so educated now. I'm going to go off and become an awesome filmmaker. So, camera is actually a tool for recording light. So, if you have a camera here, and you have a person that you're taking images of, and you've got, let's say, the sun, then light's going to fall on the subject, and then it's going to bounce off and go into the camera. So the easiest way to figure out how a camera works is actually to follow that path of the light from the subject into the camera. So let's take a look at that. The first thing that you run into in the camera is at the very front you have a lens. And this can take a lot of different forms, but in general the job of the lens is to take the light and to focus it, because you're taking something large like a person, and ultimately down the rest of this process you're going to be recording it onto a really little bitty thing. That's where the light's going to go on. So you have to be able to take these lines that are coming in here and make them all point down in focus into this little tiny thing. So that's basically why you need a lens, is so that you can focus it onto a much smaller surface. So the primary purpose of a lens is for focus. So that's mostly what you're going to do with the lens itself. And you do that by twisting usually the very front element of the lens controls the focus. And just if you're curious, what that focusing mechanism does is it actually moves the surface of the back of the lens back and forth to be closer to the actual recording medium, so that it gets the sweet spot of those converging lines just right in the spot, so that everything that you want to be in focus is in focus. And sometimes with our cameras, we have, especially in our video cameras, we have a thing that's directly behind the lens that's called a neutral density filter. And then we just call that ND. And this actually has a few different settings so that you can control the amount of light coming in. You can think of this as basically sunglasses for your camera, as I will illustrate here with my awesome drawing skills. Those are sunglasses. Yeah, so what this does is it has a part that's clear. It has a part that's, kind of darkened. And then it's got a part that's super dark. So this is on a wheel, so you can spin any one of these three sections back behind the end of the lens, and you will get different amounts of reduction of the light coming in. So the clear part doesn't do anything, it lets all the light in. The medium part says, okay, there's some light coming in, and if you spin this black, the darkest spot in front of it, it's going to reduce the light the most. So we'll come back to this. This is part of how you control your exposure, which is a concept that we'll talk about in depth. But this is your sort of first rough way of doing that. The main difference here is usually indoors or in a low light setting, you would use the clear section. Outside, when there's a whole bunch of sun, you would usually use the dark section, and there's the middle ground for the places in between. Okay, so you've got light coming in, and it goes through the lens to get focused. It goes through the neutral density filter to knock down the amount of light, and then it goes through something called the iris. And the iris is something that we're familiar with in terms of we have them in our own eyes, and it's a tool that does a similar thing to the neutral density filter, but instead of just 3 basic settings, it is a circle that lets the light in, and it can start completely open, and it can get increasingly smaller until only, so in the largest version, all of the light gets to go in, and then it closes down and it gets smaller, and finally it can be very tiny and let only a very small amount of light go through. So the purpose of that is to help us get our exposure as well. It's controlling the amount of light that comes into the picture. There are a few ramifications of this. This is the iris, also referred to as the aperture. There's an R in there. I'm going to abbreviate it as aperture. And this is, together with your neutral density, going to be in charge of most of what you need for your exposure. And exposure simply means how light or dark your picture is going to be, and the elements in that. So the light goes through the lens, it gets knocked down a certain amount by the neutral density, then it has to pass through the iris to additionally control how much light comes in, and then what you have is something called a shutter. A shutter is something adequately named that opens and shuts. This is actually what lets you take your image. In a traditional camera, shutter is mechanical, and it's usually made up out of a couple of blades that do this. They open to take the picture, and then they close again. I can actually make this like super representative. So it's closed, it opens up to take the picture, and then it closes again. So that's what the shutter does. And in our motion picture cameras and our video cameras, we don't have a whole lot of control over the shutter. We can, with a regular traditional camera, you can make that open for extremely long periods of time. So if you do stuff like time-lapse photography and you want to get long exposures, big long streaking lights and things like that, you can make the camera keep the shutter open for 3 or 4 seconds at a time. We don't have that option in motion picture because we have to do a series of images in a rapid succession. So the longest it can actually be open is equal to the frame rate, the number of shots that we have to do. So if we're shooting at 24 frames per second, then obviously we can't have our shutter open for any more than a 24th of a second. And usually it's restricted to 1/2 of the frame rate for legacy reasons that have to do with film that we're not actually using anymore. So we still actually can do a faster shutter. We can make it be open for a much shorter amount of time than we're actually need for our frame rate. And what that does, the less time that this is open, the less amount of light goes in. So you notice that there's very many factors here that are going to control the amount of light that comes in. Your neutral density, your iris or aperture, and even your shutter speed. If you make it move super fast, there's not going to be much time for the light to come in, so that will also knock it down. And finally, you have what's called a sensor. This is, back in the old days, was a piece of film, but now it is an array of light-sensitive pixels, for lack of a better term. And so when the light comes through here, it gets focused onto this plane of the chip, and each one of these gets recorded with a certain value of how bright the light is. And that's the basis of forming an image. We're using DV. So our camera uses what's called a CCD sensor, a charge-coupled device. Not that you need to know that, but it's our CCD sensor, and it has a certain resolution. What's determined here is basically how many pixels you have to work with, and that determines the resolution of your camera. So in still cameras, that's often measured in megapixels, and it has to do with when you get right down to it, how many different sections of light are we recording? If it was just 4, we would have a very pixelated, just very granular, not granular at all, very gross presentation of what the light is like, but obviously we put millions of these in here so that they can reproduce an image with pretty good fidelity. Ours that we're using for class are standard definition DV, so they're actually 720 by 480. They're 720 across and 480 down. So pretty low compared to most still cameras and modern video cameras. But then we're not done yet, because where light gets turned into electricity right here, then it goes through a processor. And there's a lot of tricks that are going on at the sensor level that the processor has to make up for. And actually, the processor does some other things in our cameras because we don't have a physical shutter. There's not actually a mechanical envelope that's closing and opening really fast. If there were, you would hear it. If you've ever used a film camera, you hear it go click, 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 like that. That's the shutter opening and closing really quickly. And if you use an SLR camera, you'll hear the click of every time that you have the shutter opening, closing, and on an SLR you also have the mirror flipping up and down. So the processor here does a lot of things for us. It controls the electronic shutter. It also controls basically how this image gets recorded. So eventually our image is going to end up on a videotape, and this converter here processes each image as it comes in and puts it into the right format so that the tape can record it one frame after the next. And this is where my virus scanner kicks in. That's pretty awesome. This is where the actual frame rate that it records at is done, because our camera can shoot at 60 frames per second, or it can shoot at 24 frames per second, or a couple of very different options there. So the processor here is doing this. It's also in charge of things like color balance. So if the light coming in here gets recorded a certain way, there's settings on the camera where you can tell it, you know, what color within all of that should be white. And so things like white balance are done in the processing of the image. In film, that used to be done chemically based on the type of film that you had in your camera, but we're able to do that all in the electronic portion, in the digital portion of the image manipulation. And so that's what happens here. And then finally we get our tape action, where our image is fully recorded and can be taken out and saved forever, ever and ever. So obviously this doesn't look like what you're used to seeing when you see a camera, but this is the process that every single ray of light goes through until it ends up finally into our recording medium. And from there, we're able to take the tape and sort of reverse the process in editing and recreate our images the way that we intended to record them. So, big thanks to our completely not made up, not imaginary person who asked me this question and got me thinking about it, so I could pass on this useful knowledge to you, so that as you have this sort of in the back of your mind as we start working with our DVX100 cameras, then you should have a pretty good framework for what all the parts do, and then we can get working on where all the buttons are.